All right, everybody, section 1.3, rates of change in linear and quadratic functions. We've already been talking about average rate of change. We're just going to dive a little bit deeper on what that means for linear functions, which again, straight lines, or quadratic functions. It's like a U or upside down U. So let's start with a linear function. It says this, that the rate of change over consecutive equal length input value intervals is constant. I know that's a lot of words. It's basically saying this, that the slope or the rate of change for a linear function is constant. It stays the same, right? So if I pick a point from here to here, the slope is the same. If I pick a point from here to here or there to there, the slope is not changing. The slope is constant. All right, so another way to look at this is if we have a table. All right, so what this whole like consecutive equal length input value intervals actually means is that our x values, our input values, are increasing by the same amount each time, right? So from -4 to -2, we're just adding 2. And it doesn't have to be 2 here, but since this one was 2, they all need to be 2 that we're increasing by. +2, +2. And if we did the same thing for the y's, they would also be the same, right? So the x's would increase by the same amount. The y's would either increase or decrease by the same amount. So in this case, we would subtract 3 to get from 1 to -2. And then we'd subtract another 3, and then another 3. Right? So over these consecutive equal length input value intervals, right, they're all increasing by 2, the rate of change stays the same. Right? The change in the y values is going to stay the same. All right, so that's a linear function. A quadratic function, this sentence looks very similar, but there's one key difference at the beginning. It says the change in the average rate of change over, again, that same phrase is constant. All right, so it is not true with the quadratic function that the slope is staying the same. It's changing, okay? But it's saying that if we find the change between these, that's staying the same. All right, so let's see what that means given this table here. So first off, the x values are all increasing by the same amount each time, right? So we're adding 1, so that checks this part. Again, the consecutive equal length input value intervals, they're all the same. The y values, though, let's see. So we're going to increase by 5. Increase by 5. That was ugly. That's a 5. Then increase by 3. Then increase by 1. So these numbers were not the same, okay? But if we find the change in these numbers or the difference between them, in other words, how do I get from the +5 to a +3? Well, I would subtract 2. And then again, how do I get from 3 to 1? Well, I'd subtract another 2. Right? So these numbers are the same. And that's what it means by the change in the average rate of change is constant. Now, another thing we can determine about this quadratic function is based on this number, if it's positive or negative. So at the end, if that number is negative, it actually tells us the function is concave down. It's opening down. If that number, or those two numbers were both positive, it would be concave up. If those two numbers were different, it's actually not even quadratic. It's something else, and we got to keep working until we find what it is. That'll be another lesson, not this one where that happens. All right, so just to spell this out for you guys, for quadratic functions, if the change in the average rate of change is positive, that tells us that the function is concave up or opens up. And then if the change in the average rate of change is negative, well, the function is concave down. All right, so let's look at a couple tables, and we're going to try to determine first, is it a linear function or a quadratic function? And then if it's quadratic, is it concave up or is it concave down? All right, so I've got two different tables here. So let's just double check first. Are the x's increasing by the same amount each time? And they are. All +2 here. So now let's look at the y's. Let's see, are those increasing or decreasing by the same thing? Well, we subtract 4, we subtract 4, we subtract 4. Right, so if the y's are increasing or decreasing by the same, and as long as the x's are equally spaced, that tells us the function is linear. So this function is linear, again, because the y values were all increasing or decreasing by the same amount. Its rate of change is constant. Now, second table. Again, let's just double check, are the x's equally spaced? They are. We're adding 3 each time. Again, that number doesn't matter for determining if it's linear or quadratic. They just have to all be the same. Now, the y values. They start off, they increase by 1. Then they decrease by 1. Then they decrease by 3. So, it's not linear. That's what that tells us, all right? And based on this lesson, it's going to be quadratic, but we're going to add to this eventually some other types of functions. So, let's confirm it's quadratic. Well, from 1 to -1, you have to subtract 2. And then from -1 to -3, you have to subtract 2. Right? So because these two values are the same, right? Both -2, or it doesn't have to be -2, they have to just be the same. It's a quadratic function. Okay, that's the first part. This is a quadratic function. The second part is a concave up or concave down. When you look at the sign of this row right here, these are both negative. So because they're both negative, it's concave down. Concave down. And you could also figure that out just by plotting those points on an XY axis. And you would see, just to do a very quick sketch, if you went right 1 and up 6, right 2 and up 7, right, oh, sorry, shouldn't have gone right 1, should have gone left 1. That was a -1. So left 1 and up 6, okay, right 2 and up 7, right 5 and up 6, and then right 8 and up 3. And those are, again, just ballpark. You can see this quadratic function opens down, it's concave down. All right, that's it. It was a pretty short lesson. I will say one more thing, though, that I almost forgot. So I know this is a mouthful, but if you want to get some extra credit, you guys could memorize this, because this will actually help you on the AP exam at the end of the year. If you have the quadratic definition of its rate of change memorized, and the linear definition. So if you guys have both of those verbatim memorized, I will throw some extra credit on your next quiz or your next test. All right, but that's it. Stay flawless.